Welcome to Space Tech Insider.
Imagine satellites orbiting our planet, each following a unique path. Some zip over the equator, others crisscross the poles. But can any rocket take a satellite from any launch pad to literally any of those orbital paths? The direct answer is no. Not every launch site can efficiently reach every possible orbital inclination. Launch sites have specific limitations and advantages. When it comes to the range of orbital inclinations, they can achieve without significant penalties. The main reason for this limitation lies in something called the Earth's rotation. When a rocket launches, it naturally benefits from the Earth's spin, which provides a free boost of speed, essentially flinging it eastward. This inherent eastward velocity means it is easiest to reach orbits that match the latitude of the launch site or are slightly higher in inclination. To go against this natural boost, for example, to launch straight north or south from a mid-latitude site for a polar orbit, or to reach a lower inclination than the launch site, takes a significant amount of extra fuel for what is known as a plane change maneuver. This maneuver requires a lot of energy to alter the orbital path once in space, making it very expensive and often impractical for large payloads. This means when planning a space mission, the choice of launch site is crucial. If you need a satellite in an equatorial orbit, launching from a site near the equator, like Kourou in French Guiana, is highly efficient. For polar orbits, launch sites further north or south, such as Vandenberg Space Force Base in California, are preferred because they can launch directly over the poles without needing a large inclination change. Trying to force an equatorial orbit from a high-latitude site would mean carrying substantially more propellant, significantly reducing the payload the rocket can carry. This efficiency factor explains why specific launch sites specialize in certain types of missions. For instance, an equatorial launch takes full advantage of Earth's rotational speed, minimizing the need for costly plane change maneuvers that consume significant fuel. Attempting a major inclination change often means the rocket has to perform a dogleg maneuver shortly after launch, which is a complex trajectory adjustment to avoid flying over populated areas while redirecting its path. Each degree of inclination change demands a significant penalty in payload mass, sometimes as much as 20% for a large change. Understanding the relationship between launch site latitude and desired orbital inclination is key to designing efficient and cost-effective space missions. It ensures that valuable payload can be delivered precisely where it is needed without wasting precious fuel on unnecessary orbital adjustments, optimizing every launch for its specific mission goals, and maximizing the scientific or commercial return on investment.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.